This hit and run econometrics is on testing for structural change. And in testing for structural change, I'll invoke something here from the stupid list. Things to know to avoid making stupid mistakes in econometrics. If you're testing for, and put the phenomenon there, the null hypothesis is often no. And then you put that phenomenon there. Thus, if there were an outback test for kangaroos, the null hypothesis would be no kangaroos. Well, there are some times when a model changes so much that we say the entire structure changes. And so there is a Chow test named after the econometrician Gregory Chow for structural change. Chow test for structural change. And now, what do you think the null hypothesis is? Yeah, pat yourself on the back if you said no structural change. Let's see how this works. The logic of the Chow test and why this would tell us when we had a structural change. The logic of the Chow test goes this way. We're going to run a model 3 times, one for an overall period during which we think a structural change occurred, and then once for each subperiod. So if we think the world changed in 2008 or 1992 or whatever year we want to pick, we're going to run the model 3 times, once for the overall period, once before our break year, and once for after our break year, and then we'll see if there is a break. If a structural change has occurred, then the overall model should fit badly. Why do we say that? If there's been a structural change, the overall model will fit badly. Well, there's why. And there's a good old X2. And let's say we're looking at this data set and we see, it looks as though when X2 goes up, Y goes up. But then, as these variables continue to grow in macroeconomic history, there comes a time when X2 seems to bring Y down. Now, we would like to know, was there a structural change about there? We can just, kind of eyeball it and say, well, it looks kind of like a structural change was there, but we want a formal statistical test, so we're going to use the Chow test. How do we do that? 3 regressions, one for each sub-period. This is for sub-period 1. We just fit a line to these points that it seems to fit. And then we fit to these points over here a second model, and then we just throw them all in together and say, well, let's fit a model to the whole overall period. And so ordinary least squares will come in and it'll draw something that looks like that, and we'll label that with a T to think of it as the overall period. So the logic of the Chow test is that if a structural change has occurred, the overall model should fit badly. If these points were a little less distinct, then it would be a little less obvious here that there had been a structural change, and we would definitely want the backup of doing a formal statistical test. So how do we do that? How do we test for structural change? Well, here's what we do. We run regressions for periods 1 and 2, and we make note of RSS1 and RSS2. That would be the sum of the squared residuals for period 1 and for period 2. The computer is for us going to calculate each residual, distance from the point to the line, square that, add it all together, it's going to be the sum of squared residuals. And then the regression for the whole period, we're going to note the sum of the squared residuals for the total period. So now what's going to happen is that the computer is going to be calculating the distance from out here in this point to the now farther away line, and it's going to be squaring that and putting that all in a pile and calling it the sum of the squared residuals. The Chow test relies on an F statistic, and here it is, an F statistic. It has degrees of freedom of k plus 1, and then n1 plus n2 minus 2k minus 2, and as we'll see, that N1 and N2 are the number of data points in each one of those samples. I wanted you to have a look at the Chow test statistic, which is an F statistic. There's a lot of calculation here, but all of the action is in this first term. That's where the action is. If we have a structural change, then the sum of the squared residuals for the total period is going to be a huge number. Doesn't come close to a whole lot of points. And then we're going to be subtracting off the sum of the squared residuals for period 1 and the sum of the squared residuals for period 2. And in both of those subperiods, the model might fit superbly well. If it does, that's going to be a big difference. And the rest of this is just putting this into a form where you can use the F distribution, this F statistic. If, on the other hand, you didn't have a structural change, you would find that the total model fit about as well as doing it separately in models 1 and 2. So once you've got that test, and let's see what we're saying here. K is the number of slope coefficients. N1 is the number of observations in sample 1. N2, number of observations in sample 2. The null hypothesis is no structural change. There we go, from the stupid list. And you reject it for a high F number. But you're not looking for the F number. You don't know what a high F and a low F is. I don't know what a high F and a low F is. Instead, we just go look for the p-value. Because we know for the p-value that's equal to or less than 0.05, we're going to reject that null hypothesis of no structural change, and we're going to conclude that we do have a structural change. And I'll just conclude this example with the 4 most dangerous words in investing. This time it's different. The 4 most dangerous words in investing are this time it's different, according to John Templeton. Yeah, this is what Sir John had to say about it. He said that at stock market tops and bottoms, investors invariably use this rationale to justify their emotion-driven decisions. Yeah, so when the market is hitting new highs, you say, this time it's different. It's never going to stop going up. And that's what causes the so-called noise traders to put even more money in the market then. When the market is headed down, hits bottom, and it's always bounced back before, but people say, this time it's different. Stock market's never going to recover. I'm getting out while the getting is good. Well, is this time different? After enough time passes to do a Chow test, you can figure it out. And I want to show you now how somebody who really came into this not knowing much about the Chow test and not knowing SAS, that statistical program, could simply use this example, a Chow test of structural change in the stock market. And this Chow test deals with the historic year 1992. The dependent variable that is the S&P 500, which is one measure of overall stock prices that some people like to use. And what we're asking is, hey, did the internet change everything in 1992, often picked as a breakpoint for the year it took off? Did it change it so much that there was a structural change in the stock market? Up until that time, the S&P 500, it was said, was highly dependent on manufacturing profits in the economy because, hey, only with manufacturing could you make an economy strong, right? Hey, that service sector, that's not such a big deal. And the companies like General Motors and IBM, all the big manufacturing companies, they thought that they were the economy in a way. So what you could do is come across this output. All you have to know is that a Chow test is being done. And it's a Chow test on the relationship between manufacturing profits and the S&P 500. Did it radically change in 1992? So you put it in, you get a whole bunch of numbers, whole bunch of numbers, whole bunch of numbers. But what you're really looking for is the Chow test. And the Chow F value is 7.21, but you don't care much about what that means because the p-value on that F test is so low. It's below 0.05 and it's below 0.01. And so what do? We reject the null hypothesis. The null hypothesis said no structural change, and we're saying, oh yes, there was a structural change. There was a structural change in the relationship between manufacturing profits and the S&P 500. In the year 1992, we get confirmation from the Chow test. After 1992, no longer would American stock prices be so dependent on manufacturing profits as they had been before 1992. That is just a fun little test for structural change, but I think it's a nice example that shows you how the Chow test works, and perhaps even more importantly, how once you learn the name of a test and the null hypothesis of that test, then you can go do the test. Go look up in whatever statistical package you're using how to do that test. You will find lots of different values of variations on the Chow test there in the R community. And let me just say, if you want to do it the hard way, the old-fashioned way, just go run those separate regressions and go look for the residual sum of squares in the output of those three. Plug it into your calculator right there, and you have a Chow test for structural change.